Great. Thank you so much, Sagar. Those were some amazing insights to the serverless framework. We will now move on to our second presentation, which is brought to you by Dhee Nath on the topic of data Blissformation, Unveiling the dbt dilemma. Can I please get a round of applause for Dhee?
All right. Good evening, everyone. How's everyone feeling? It's a big turnout today. Awesome. Can you all hear me okay back there? Fantastic. Cool. So my name is Dheerendra. You can just call me D. I'm a principal engineer with Kasna. Kasna is a brand of Mantle Group. We have many brands, and Kasna is a Google exclusive brand. So we do everything for Google Cloud. We work with big clients, big projects, data projects, infrastructure, app modernization. We do everything. But today I want to talk about big data. I've been in the data and analytics space. I've been working for like maybe 17, 18 years with big data now, and Google Cloud especially for about 7 or 8 years. So yeah, there's lots in Google Cloud, and today we'll only look at one little aspect. It's not a coding demo or anything. You've done enough coding for the week. It's Friday evening. You've had pizzas and drinks. So this is going to be more of a thought-provoking blend of architecture and cultural discussion, all right? So I want your participation. We don't want it to sound like a lecture. So there's Gishan, and yeah, I think there's few people carrying the mic around who'll help you jump in and answer. So first things first, we run a podcast called GCP Live. It's sponsored by Kasna. It's a very famous podcast. Subscribe to it. You get to hear all the latest and greatest in GCP from the experts. It's really fun. It's a great thing to hear. Let's start with monkey business. Who doesn't know the 5 monkeys experiment? I mean, I know, so I can't put my hand up, but okay, you guys don't know. There's quite a few people. I'll very quickly summarize what this one is. It's very popular, actually. So I think it was Stanford University, where they picked 4 monkeys and put them in a cage, didn't feed them. So of course, monkeys were really hungry. And then there was some bananas hung on the top of the cage. Obviously, hungry monkeys would reach for the bananas, but monkeys hate cold water. So as soon as any monkey went to reach for the bananas, cold water was sprayed on them. And they hate that. So after some time, they learned not to do that. So every time they would reach for the bananas, they would get a shot of the water. They would refrain from doing that. They learned it. That was the common practice. It became the culture for those 4 monkeys. One monkey was replaced with a brand new monkey. Now this brand new monkey is new to the organization, doesn't know the culture, doesn't know the ways of working. Hungry monkey reached for the bananas. The other 3 monkeys beat this monkey down. Now this monkey doesn't know why am I getting beaten up. But after some time, the monkey understands, okay, don't reach for the bananas. Mind you, cold water was not sprayed even once. But the other monkeys conditioned this new monkey. After some time, another old monkey was replaced with a new one, and so on and so forth. And after some time, there was no original monkey in the cage. The 5th monkey was a brand new monkey which had never experienced cold water. And still it would not reach for the bananas. So the monkeys were totally conditioned. So the 5th monkey syndrome, 5 monkeys experiment. It's extremely popular. It talks about company culture. You can see this everywhere. When somebody says, this is how things are done. This is how it is done. This is how we've been doing for a long time. That is 5th monkey syndrome. A good example would be rituals, traditions. You get the idea. So why are we talking about monkeys and monkey business? It has a lot to do with what we're going to discuss about today. So we'll go on a journey. We'll take the journey of data architecture. There's 4 generations. We are in the 4th generation of big data right now. So we'll cover that journey. We'll see the challenges that all those 3 generations have faced. We'll understand what today's challenges are. And then we'll do a bit of like retrospection and introspection on what's valid, what's not, what needs to change, and what's cultural and what's practical. Any questions at this point? Anyone has any ideas, thoughts? Any more monkey business to talk about? Right. So when we say data architecture, what does it really mean? In simple words, it's basically creating a data-centric organization, right? A culture where people use data to do their job. They talk in terms of data, they make sense out of data, and they use data to collaborate effectively. So data is the central piece or medium of communication between people. So that's the culture. So we are striving to establish a data-driven culture. Should we sell more purple-colored shirts? It's not a yes or no question. It's not about we always sell purple. No, we sell all colors. But should we sell purple more? It's based on data. So I just picked this little excerpt from a blog. You'll get access to this slide pack. So go read that blog. It's really fun. So first generation of data warehouses, way back in 1980s, right? What was it like? There would be a lot of different applications. On the left-hand side, you can see the yellow one, operational data plane. So that's typically like a web application where you have a OLTP, relational database, which runs transactions. We can't do analytics on it because this database is designed for transactions. So how do you run big analytics queries? You first have to move that data into an analytical database where you can run large queries, where you can do a lot of joins, and you can work with large volumes of data. So the concept of ETL, data pipelines, was born. It's before we were born, actually. So it's been going on for a long time. SQL was invented in 1975. We are still working with it. So that was the first generation of data warehouse or analytics. And then we would use that data for maybe driving reports or dashboards or generating those kind of business insights. Question for the audience. Who is still working on this kind of stack? Where you have transactional, relational DBs. Your favorite DB, Oracle DB, MySQL, Postgres, ETL pipelines, bring it to an analytical DB and do analytics. Anyone wants to add to that? You want to share your experience or say something about it?
I want to add. I think I saw very less hands, but probably people are not actually saying. But I guess most data pipelines still.
They're just shy. They don't want you to tell their age. That's why.
Most pipelines I know still work with this, where we have a OLTP database and something that moves the data to an OLAP.
Yep.
AP database or something of that sort.
That's right. So the question is, do you love it? Don't answer that. Hold on to your answer. So what were the hallmarks of this? There's SQL, there's ETL, there's batch processing, and there's data marts. You all have heard these keywords, but now you understand why these exist, where these come from. Before we were born, guys, come on, seriously, please. So SQL, structured query language, because it makes it easier to question data. ETL, extract, transform, and load. You have to extract from that yellow thing and transform it because it won't fit into an analytical DB. And then load, you have to load it into the other DB, right? So ETL was born. Batch, why batch? Because, guys, compute is expensive, storage is expensive. So how do you eat an elephant? You eat it in pieces. So you have to break your data down into small batches. Have you made check payments? Why do check payments take 2 days? Because your bank has to batch up all the checks for today, send it by mail to the other branch, goes there tomorrow, and then comes back and batch payments. You love batch payments, right? So don't use online payments. Data marts. We'll talk about data marts. So I'm a sales team. I want my data to look in a certain way to run sales campaigns. You are a marketing team. I don't trust your data. I want my data to look my way. We don't share data. We don't talk to each other. But we work in the same company. We don't love each other, but we tolerate each other. So I want my data my way, my mart. You can have your data your way. I don't care. That's data mart. Talk about company culture. So what are the problems or drawbacks? SQL used to be specialized skill. Used to be, not today, used to be. People were paid heavily. ETL, has problems with formats. There's CSV, JSON, Avro, Paki, ORC, God knows what. So there's lots of patterns. Batch, oh, well, we've talked about it. It's resource hungry, storage is expensive, compute is expensive. Break it down into batches and just keep doing nightly things. Don't do real time. And data marts, we just don't trust each other's data. Second generation, again, this is quite old, 2000s to 2010s. More of a data lake architecture where companies decided, no, this batch thing alone just doesn't cut it. Data marts are not enough. So we need to do more. We need to make data pipelines simpler. We don't want to extract, transform, and load. We just want to load this data in raw format because we can't rely on transform data. We want original data. So we'll just load everything and then transform it. So ELT was kind of born. But how do you transform data in database? Ooh, that requires a lot of compute power. So that's when MapReduce was kind of born, and we started doing big data processing. Spark, Hadoop, Cassandra, like Hadoop used to be highly paid job. I used to get paid heavily to do Hadoop and Spark, but anyway, that's old story. So what are the hallmarks of this architecture? Get data raw, acquire raw data. We load it and then transform it. Don't do ETL. So we don't need smart pipelines, just dumb pipelines, load your data and then transform it. So MapReduce, because SQL can't really do this kind of transformation, so we need MapReduce. How do you run MapReduce? That's a different question. The concept of jobs. If you're transforming everything in the DB, then there's dependencies, right? This pipeline has to run, then that pipeline has to run. When both are ready, then run something else. If something fails, then happy birthday, go fix everything. Your weekend is gone, but you know the deal. So the whole job, orchestration, dependencies. And then that's where the concept of data modeling was born. Load everything, transform everything, model it. So these were the challenges. Getting raw data means it takes a lot of resources. ELT takes a lot of processing. You need a lot of compute power. So distributed computing was kind of born. MapReduce was the highly skilled job then. If you knew MapReduce, you were the king. You would ask for big pay, and you would be paid. Jobs, dependency. So you have the whole need of orchestration now, dependency management. And then model. I mean, come on, guys. Data mart. We don't trust each other's data, right? But now we are saying, no. We'll centralize all the data together. We'll create a data model, and we'll call it data vault. You all have to trust it, but who guarantees this data is correct? How can I trust this data? I didn't create it, you didn't create it. Who verifies this? So that's why the concept of data governance was born. Somebody has to verify it, right? So yeah, the system, somebody. And then we always had the baggage of first generation. Because people don't like change, they still like to hold on to bad jobs. So we had first generation along with all these things. Then come to the third generation of cloud data lake. Why is this different? You can see the 3 stages. The first one is data warehouse, first gen, because people love bad jobs. They don't want to change things. Second one is the data lake, because we've just invested so much money to build it, so we don't want to throw it away and lose our jobs. That's there. And the third one is data lake house, because we need to keep changing things, guys. We need jobs, right? So that's not the point. The thing is, the hallmarks of this architecture are streaming data, data blending, serverless. Rings a bell? You just heard about serverless a few minutes ago. And then lakehouse. Fancy terms, but streaming data, right? Because suddenly people begin to understand we don't like check payments. We don't like, couriers and postages. We want things fast. We want things real time. So we want streaming data. But we always have this first generation thing where everything is batch. So how do you mix those two together? We need data blending. And then it costs so much to run all this. Hadoop clusters, Cassandra clusters, and all these VMs and servers, and then racks and storage and patching and data centers. And dude, I need to rob a bank to run a bank. So we need serverless. We need to make it cheap. We need to make it convenient. It should scale automatically. So serverless. We need to give it a new name, otherwise people won't know it is new, so we'll call it Lakehouse. So these were the challenges. The moment you say streaming, you have a user experience problem, because data is changing so fast. How do you know which one's new, which one's correct, which one's old? Data blending is complex. Dude, come on. SQL, it used to be a specialized skill. Now it's not. MapReduce used to be specialized. Now it's not. Now you need to blend both of them. It's complex because you just don't have enough people who know these things. Serverless is an operational complexity, right? It's serverless. So if I run a 35 terabyte query, you will have to sell your house. So it's an operational expenditure problem. Lakehouse, well, everything is centralized. No more data mart. Everything's together. And of course, you have the baggage of first and second generation because we don't like to change things. That's how we always do things. It's culture. So where does it leave us? So if you just look at these things in the box, this is the first time I'm going to use the word dbt. You guys are probably here to hear me say dbt, so I'll call it out now, dbt. This part in the box is tricky. It's hard. Because you have dependencies, you have bad jobs, you have failures, you have dependencies to manage those failures. So how do you run all this? Your data arrives, you have to create a table. If the schema changes, you have to upgrade the table. And then you also have to take care of stored procs if you have any. The moment your schema changes, your queries change, your APIs change, everything changes. It's a nightmare. So you need a code base, you need a project, and you need to version control it. But it's so much complexity, you need to test it. But now you need environments, and now you need DevOps to manage all those environments. So you need a tool to handle all this. And that's why, congratulations. Somebody comes along, builds something like dbt, because it does make it easier. It removes the pain. It automates the whole SQL workflow orchestration headache. It's a godsend. It's a great thing to do. But so that's the whole deal about dbt. It's got version control testing and all those things built into it. Any questions or thoughts at this point? Anything from anyone? You guys are not participating. You're not having fun? All right. So let's move on if there's nothing else. Gen 4. This is what we are supposed to be doing today. And you'll hear a lot of businesses and organizations say, we are moving to data mesh. We are adopting data mesh. We are implementing this new architecture. Architecture, again, guys, architecture. Come on, it's supposed to be fun. So look at how it's put together. The different colored boxes are different pillars. It's also commonly called as the 4-pillar architecture. Everything in the yellow ovals is basically your data products. So now there's no concept of ETL and ELT and OLAP and OLTP and stuff. It's all about marketplace, producers and consumers. Think about the Sunday market. If I am a crafty guy, I can make something. Geshan is a crafty guy, he makes something else, and we just sell our things. People who like our things, they buy it from us. They don't care how we created those. So each team, let's say sales, marketing, analytics, they all create their own data. It doesn't matter how they got their data or how they process their data, but everyone is free to share their data with each other through APIs. It's a data marketplace. These are the hallmarks, prosumers. Everyone is a producer and a consumer, right? Everyone is a producer of data and a consumer of data. And we don't talk about models, we talk about data as products. Because I'm putting a product out there on the marketplace, you can subscribe and use it if you like. And then there's governance, which is central. So there's data discovery, metadata management, and all that at the platform level. And then self-service. You don't need permissions and approvals. You just go to your data governance tool, look for data you like, subscribe, start using, and publish data as well. So it's basically a microservices architecture for data. It's nothing new. We've been doing this for web apps for a long time, but now we've brought it into data domain. Who's working on data mesh right now? Or who believes they are working on data mesh right now? No one? Nothing? Okay. Yeah. Mike, please. Oh, you think? That's good. We are in the same boat. All right, moving on. So the whole Gen 4 data mesh philosophy is around this fact of marketplace where we exchange data. So Where does this leave us? So Gen 1 is all about SQL batch, data modeling, data marts, Gen 2 and Gen 3 are about centralizing things. But Gen 4 is about distributing things. There's a fundamental difference. So we spent the last 35, 40 years centralizing everything, bring everything into one place, lake everything, model everything, mart everything, and now suddenly we say, no, break up the power and give it to the people. It's free democracy, no more dictatorship here. So oil and water, right? They don't mix. Centralized is not distributed. You can't mix both of them. So this is a problem. This is a big problem now. Why? We've established that distributed and centralized are not equal. We've understood that these things don't get along with each other. So focus on these boxes. SQL, batch jobs, data marts, and data model. So these are on the right-hand side. These are all about batch jobs and dependencies or orchestration. But Gen 4 is more about keeping things asynchronous, event-driven, use APIs, and treat as products. So we are fundamentally contradicting each other. That's exactly what dbt does. And Alexander Potts is falling asleep now. Exactly. So this is a problem here. The SQL workflow thing just doesn't fit into the whole Gen 4 philosophy. We say we want to use dbt and SQL workflows, but also do data products and streaming in asynchronous real time. It doesn't mix. So this is where the whole blissfulness element comes in. SQL workflows used to be fantastic to centralize things and manage those dependencies. But the moment we say we are taking an API-driven approach, they typically don't really solve the problem. And I use this word blissformation. Actually, there's no such word in English. It's blissful information, which I wanted to convey. So it's an information, but the Gen 1 adherence or SQL workflows just make it easier to kind of hold on to the batch processing mentality and not move on to Gen 4 and more streaming in real time. Do you agree or disagree? Like, what are your thoughts? Or does your manager or boss say, like, this is how it is supposed to be? It's what it is done. Or is your boss in the crowd so you don't want to say? Yeah. So this is the key thing. Look at the differences. SQL is ACID. Anyone knows what that stands for? You want to enlighten the crowd? Atomicity, consistency. Yeah. So it's all about transaction management, right? You want to be able to make transactions and keep them coherent. But the Gen 4 API mentality is eventual consistency. We don't want anything to be consistent. Come on, consistency is dependency. Break it up. SQL is complexity, API is simplicity. Nah, everything should be JSON. Right? SQL is batch, and API says, nah, everything should be event-driven. I don't like checks being cleared after 2 days. I want, OSCO payments right now. Right? Cumulative. SQL is cumulative. How do you run SQL? You need to scan the whole table first, and then you group by, and then you order. So the way it works is cumulative, but your APIs are dissective. Break things up. Look at field by field. If you use jQuery or something like that from the website, SQL is slow, you have to face it. Otherwise, Oracle would do everything. SQL is slow, it needs a lot of resources to compute. APIs are fast, right? You can run API on your shell. And then SQL is expensive, big databases, licenses. APIs are cheap, come on. Do you pay for JSON? And then lastly, SQL is rigid. You have a schema. You have to manage the schema. API is schemaless. There's no schema. Have fun. So this is the fundamental difference. So the question is, do any scenarios really exist for a SQL workflow in 2023? Who wants to answer that? Nobody. Come on. Go ahead, Gishan.
Yes.
Elaborate, please.
I mean, probably like 50 or 60% of actual real data is still in SQL databases, right? So someone has to move it from that to an OLAP or I don't know, like a BigQuery or something. So I guess even now, probably 50-60% plus work of a data analyst or a data engineer is still writing SQL. So it's not going anywhere, at least for the 5 or 10 years I can see. That's how I would elaborate.
Yeah, that's good. That's definitely one of the items on the list. So yeah, you have definitely answered a few of those. Anyone else? Any ideas? Yeah.
I'm wondering if you want to publish events that are somewhat abstracted from the your physical data model.
Yeah.
Maybe SQL might be a way to achieve that.
Yeah. Anyone else?
In the database land, a lot of the transactional databases are now going to the edge and are all SQLite.
Yep.
So that sends the message that, at least in the next 10 years, that most of the new databases that application devs are adopting will all be SQL-based and also distributed. So lending yet another problem to the whole ingestion into your data lake.
Yep, that's right. I love this crowd. So you guys are making my job easier. I should actually include all of you in my next presentation because you have actually answered all those points there. So the first one is legacy DB lift and shift, right? Which is pretty much what it sounds like. You have something running on-prem, it's legacy, DB2, you don't like it, company won't let it go, it's got 35 years of data. It has to be that way. It's got stored procedures. People who wrote those stored procedures are retired or dead, so you're just stuck with it. So migrate it over to the cloud, lift and shift, so you are stuck with SQL there. If there's PL SQL, then yeah, I mean, good luck, you gotta live with it. So how do you make it easier? You can use dbt to kind of simplify all that. Because now you don't have to manage the schema and dependencies, and you can just focus on the business logic. You can define the business logic in a more modern language, YAML style config, right? That's one. Sometimes you might have a database which is pretty stable. There's no need to change it, it just works. In application space, you might have a war file which is perfectly fine, but it's just expensive to run, so you'd containerize it and run it on Kubernetes or put it on Cloud Run, which is Geshan's absolute favorite, I know that. So do those things. How do you do that in data space? Yeah, just wrap it up. I mean, put it on cloud and run it with dbt. So that's pretty much your APIification in a way. You can also do archival APIification. It's all basically the same thing. You wrap it up. Data mart, pretty much the same thing. You have a data mart. It's built already. You don't need to change it. Just want to use it. Hide it behind an API. So you can do that with dbt. And lastly, you're running stuff on-prem, regulatory. You're not supposed to put it on the cloud. It's got sensitive information. It has to be on-prem. You can use dbt to simplify that pain. Again, use dbt to publish it to a message, and then consume it from there. But watch out for these gotchas, okay? These are your organizational smells. So if you go back to the very first slide, the monkey business thing, when you hear, this is the preferred tooling, this is why we need to use dbt because we prefer it, or this is how we've always done it. Those are not the real use cases. Those are not the reasons why I should be using those. It's very hard to get approvals or clearances, or this is the skill set we have in the team, or that key person, that director has stipulated, mandated this tool, dbt. Watch out for those. Those are the points where you're probably dealing with a cultural conflict and you should question those. Okay? So we are almost at the end of the presentation. Quick resources for you. So how do you make architectural decisions? That's a very famous quote, and I absolutely love it. If you pick the tool as the center, at the center, and define your architecture, then you end up treating everything else as a nail. If you say, I want to build my data platform with dbt, you've already made a mistake. It's like you want to live on an island, but you want to run an EV. Good luck. So it's like that. You have to pick the right tools for the right job. All right. Always focus on the business. What exactly is your business goal? Your users who are going to use your product. Then you have to think about your own people. Why are these three really important? What's exactly your business? Are you a data-driven business? Maybe not. Do your users really use the data in a data mesh way? Maybe. Probably not. Do your own teams trust each other's data? Do your teams like to exchange data? If yes, then fine, data mesh might be the solution for you. But if your teams build their own marts, they don't share data, then maybe it's not the right solution for you. And lastly, culture, like how collaborative you are. Do you collaborate with data? Do you use data to make decisions? And then constraints. Sometimes you probably may not be able to run things on the cloud, or you are just stuck with some regulatory requirements. So start with the Google Architecture Framework. It's called the well-architected framework. It's got all these different pillars. So any architecture or design should follow these principles: cost optimization, scalability, et cetera, and you don't have to start from scratch. There are a lot of well-architected solution designs to start from. So use those as a starting point. Whether you're building a data platform, smart analytics, ML platform, app modernization, migration, anything. Google has like hundreds of reference architectures. Pick one of those and refine that to suit your business case. Any thoughts on this? Has anyone used the Google reference architectures as a starting point? If not, you should start using that. Can make your life easier. The most popular ones, if you still have to use SQL workflows, are dbt and Dataform. We're not going to dive deep into those because, of course, you can just do a Google search and learn all about that. But they pretty much do the same thing, as the name suggests. They help you orchestrate SQL workflows. So you data transformation jobs, dependency, orchestration, scheduling, built-in data quality checks, so some testing, metrics, run metrics, the ability to rerun things, and DAG, so you can see the dependencies. So it's basically the same thing. They both do the same thing. There's no difference. So where is the difference? I asked Bard, tell me the difference between these. It gave me that. Don't worry about it. You can ask Bard yourself, so I'm not going to read all of that. I've just summarized that here. So there's two types or two variants of dbt. One is dbt core. Now it's SQL, but YAML based. So SQL workflows, right? You're only using SQL. You're not doing any other programming language. But it's YAML based for config. And there's a CLI. You have to host it yourself, dbt core. So which means you need compute infrastructure management, which means you need to have a DevOps capability. You need to understand infrastructure. You need to do security patching and all that. Think of it as on-prem, but on the web browser. Okay? But it's free. So yeah, I mean, it's free. So the other variant is dbt-cloud, which is on the cloud, so you don't need a DevOps capability. You don't need to do any of the infrastructure thing, all the serverless beauty, right? So you got it there. And the bonus is you also have an IDE, so like Eclipse or VS Code style developer experience, but you have to pay for it. There's a subscription, so make a decision. You want it free or paid. What about Dataform? Well, Dataform is a fully managed service on the Google Cloud, just like Cloud Functions. So you don't have to do any planning, any capacity planning. You don't have to operationalize it. It's taken care of by Google. So it's managed by the world's best DevOps team, Google itself. Like, do you ever call an 1800 number and say my Gmail is not working, and do they tell you to restart your laptop? Like, so they manage it for you. So it's not going to crash. It's got IDE as well as CLI, so it's on the cloud. You got an IDE, you can organize your projects and do stuff. It's fully managed. Okay, it's integrated with security and all the niceties of Google Cloud. Best part is it's free. So if you really wanted to use dbt the fun way, you would have to pay a subscription, but you get it for free on Google Cloud. So why pay for it? I mean, we like free stuff, right? So that's there. The only difference is dbt is YAML based and Dataform is JavaScript based. If you are moving to Gen 4, if you like to make everything API, I mean, you're a smart person, so make a decision. You want YAML or JavaScript? Lastly, just wrap everything up. Always focus on the primary business, like that's your primary consideration, what your business does. Things like who your users are, what your SLAs or objectives are, and use that to make a decision like whether you want to build any AI platform or an ML platform. Think about it. Who's going to be the people element, like your teams, what are their goals, how do they interact, what sort of skills your team has. And then also think about the secondary considerations, because that should go into the architecture. Architecture should not be primary. Don't think like I need a serverless architecture, and think about what you want the architecture to give you. Don't just say, I want to build my platform on data mesh. Because if your end users don't trust and share data, then a mesh is useless for you, right? Then maybe Mart is the right thing for you, but then you're back in the 80s or 70s. Good luck, cultural thing. So think about that when you pick the architecture. And then technology is tertiary. A lot of people say, I want to build it on AWS. Like, why? So think about that. Why don't make technology your primary thing? You first make a decision that I want a house to live in it. And then you think how big the house should be. And then you pick a builder to build it. And then you look at the cost. And then finally you pick the doorknob that you like. You don't start with a doorknob and say, I want a building to put this doorknob in. So tools always come in the end, right? So think about those. So lastly, pick the technology that actually enables your primary and secondary objectives. I'm an organization which is data-driven. My dev teams are data-driven teams. My business is a data-driven business. My teams need to exchange data. So I need a data mesh. Which platform is the right platform to build a data mesh? Of course, it has to be cloud, because I don't want to get bogged down by infrastructure costs and maintenance. I don't want to have a big DevOps team for eternity. And who is the best SRE team, or which cloud is the most efficient to execute things, or where is it cheap, where do I have better support, which uses open source versus licensing. Perhaps that's when Google Cloud comes into picture. It's all open source, nothing's proprietary. And then lastly, which tools will enable me to achieve all these things? Perhaps that's where you see, okay, cool, I'm stuck with SQL, so I need one of these. But don't say, I want to build a data platform, a data mesh with dbt. All right, that's all I had. Thank you, everyone. Thanks for your attendance today evening. Any questions? No questions?
Thank you. Eugene, do you think SQL will go away eventually, even in 5 or 10 years?
I don't know when it will go away, but I know that your children will still use SQL.
Okay, good answer.
It's like JavaScript. Do you love JavaScript? Who loves JavaScript? You love it? Come on. Of course we love it. It's convenient, right? So yeah. Any other questions?
So with the whole Gen form, going to microservice pattern, having done microservices 10 years on the digital side, it's been an unhappy time. So although the operational costs of Gen 4, like you said on your slide, they'll be cheaper. It's like, but traditionally with going to microservices pattern, you end up in a situation where there's more staff because there's more distribution, therefore there's more communication that needs to happen across teams.
Yeah.
You have to distribute skill into the teams. So from a business perspective, like it's probably the wrong audience, but don't you think that like the costs just get shifted into a different business unit and become a staff cost instead of an operational cost? Or what do you think about that kind of idea?
Yeah, that's definitely something to think about. When we pick a technology stack, again, like if I go back to this slide, see where skills appears on the 4th point. It's tertiary, it's not primary or secondary, but it's not at the very bottom either. So when picking the tool, we also have to be mindful of the skills availability. For example, some of our clients are big banks and they like to build things with Java. Cool, nothing wrong with Java. It's been very successful for 25 years. Java-based cloud functions are just not right, like you can't fill petrol in a diesel car. So Java is an interpreted language. It has to be compiled, interpreted, and then executed. So it's just not conducive to functions. But the bank's entire DevOps and the whole tooling is built on Java. They have Black Duck, they have Checkstyle, PMD, and all that built into their build pipelines. So that's still a constraint for them. So constraints do appear higher in the list of priorities. And skills is at point number 4. So now you're actually constrained by a skills decision. So you have to pick your tool that way. If you end up picking a tool for which you don't have the skills today, you aspire to develop a skills capability down the line, then you also have to plan for attrition. You also have to plan for training. What if you train your staff very well and they just leave? So now you have to focus on the cultural aspect. Train your staff so well that they can leave anytime, but treat your staff so well they just don't want to leave you. So you also have to create a culture to go with it, right? Yeah, so you have to balance a few things there. Does that answer your question?
Yeah, I just wanted to understand your thoughts.
Yeah, sure.
Probably we'll take a last question.
Any other thoughts, questions? Anything you didn't like or you want to challenge? Nobody challenged me. Come on, that's not fun. I must have said something wrong here.
I'm interested to know about the whole move from centralized to distributed and the complications that it creates, especially like data coming from multiple sources. Who do you trust when there are conflicting data? There are talks about single source of truth.
Absolutely.
But like you said that everyone can be a consumer and everyone can be a producer. What if someone's consuming a data which is based on multiple streams of data and then they are publishing a data, but sort of it contradicts? I know I asked a lot there, but I want to know your thoughts about complications around distributed and single source of truth and things like that.
We can make a movie on it, mate. Seriously, it's a tough nut to crack. It's a whole Pandora's box, right? And you actually articulated it very well, because the whole problem is, again, it's cultural. The problem is we just don't trust. And we don't trust because we have done shady things in the past. Nobody admits that. What do I mean by that? Like there's some data which sits in an on-prem server. We migrate it over to a warehouse. We model it. We use it for our purpose. But there was already modeled data somewhere else, but we didn't use it. We reinvented our own wheel, and we took shortcuts. We hard-coded a bunch of data because it was convenient to migrate. There was some data corruption during migration. We just flipped the flag in database like active equal to false. Forget about it. Nobody's going to ask about it 6 months hence. That's gone, done and dusted. So we know others would have done the same thing. That's why we don't trust their data. Plain and simple, right? So how do you fix it? It's a cultural problem. So the solution to this is either everyone should know how to do something or no one should know how to do something. I would prefer the latter. Okay? When automation takes care of the function, people are not in charge, and automation takes care of how things should be moved, transformed, tested, verified, scored, and published. Automation is taking care of things. It's rules-driven. There's no human intervention. There's nobody corner-cutting there. So now we can trust it. Now everyone can trust it. So if I say there is no ETL pipelines, everything is message-driven, everything is an event, everything conforms to this particular life cycle. Everything is tested, verified, scored, and ranked. Now you're not trusting humans. But it takes a while to groom that kind of culture.
Is it possible to
Fine, the last one.
Is it possible to implement data mesh like blockchain so that there are some nodes that they basically verify the quality of the data that is being sent from one?
Indeed. And that's also a key decision, to be made. For example, if you are running a bank, what's the fundamental, what's the basis for all your data? Let's make it simpler. It's a complex one. Let's say you are running eBay. Everybody knows what eBay is, right? So if you're running something like eBay, what's the basis for your business? It's products. You're selling products. So you're relying on product data. That product data has to be accurate. So that's your most prized asset. So you divert your most rules, automation resources. You divert your best minds. You build a skills capability there, and you retain it. Boy, you have to spend to retain those people, because those are your highly priced asset. It's not the servers, it's nothing else but those people. It's not practical. So you have to pick their brains, put that into a business logic, automate that logic, and test that logic, vet that logic, make sure that logic works like clockwork. And now whatever this logic produces is highly trusted data.
Yeah, thank you very much for that amazing talk.
Thank you. Connect with me on LinkedIn. That's the QR code. And yeah, like I said, I'm with Kasna. Feel free to check our website, blogs, listen to our podcast. We put out a lot of content. So yeah, stay in touch, and looking forward to see you guys again.
Yep.
Have a nice evening.
The quote of
Thank
the day
you.
for me was, I don't need to rob a bank to run a bank.
Thanks.
Yes.
Can we get one more round of applause for Dhee? Thank you so much.
This one's for you.
Thank you. Oh, thank you.
Good.
Now for the exciting part.